In this, I will be presenting the IPv4 header structure and IPv4 attacks. So in order to understand the IPv4 attacks, first of all, we should know how the IPv4 header structure is, and how the fields in this structure will help us to identify the attacks. First of all, we should know the role of each field in the IP header. Then only we can identify the corresponding traces in the network capture or packet capture, and we can analyze it. So for that, knowing of the IPv4 header structure is important. So here, this is the IPv4 header structure, which consisting of the various fields. So first of all, what is the basic philosophy or what is the basic idea of this IP? The IP is the internet protocol which is available at the network layer. In the previous lectures, we have seen the ARP cache poisoning or ARP attacks. They are the attacks that are possible at the data link layer. So now we have seen, so far we have seen the data link layer based attacks. Now we are moving on to the network layer based attacks. What are the protocols that are available in the network layer? IP, that is Internet Protocol, ICMP, Internet Control Message Protocol, IGMP, Internet Control Group Protocol. So these are the various protocols available at the network layer. Now we'll see one by one what are the possible attacks on this network layer protocols. So in this, first we are going to see the IP protocol, Internet Protocol. So the TCP/IP Internet provides three sets of services. Basically, first one is connectionless packet delivery service. Next one is second one is reliable transport service. Third one is application services, which is nothing but your TCP/IP protocol stack. So connectionless packet delivery service is nothing but UDP services. Reliable transport services means nothing but TCP services. And application services, you are aware of that HTTP, HTTPS, DNS, all these are the application level services. But for all these things, there should be to function these services. One thing one must know is you should have a proper IP address. Then only these services can be delivered or can be utilized properly. So what is this address here? It is IP address. So this IP address structure will be was shown on the screen. The IP header format will be like this. It is of 32-bit format and consisting of like a version, header length, type of service, total length, indent, flags, fragment offset, TTL, which is called time to live, type, header checksum, source IP address, destination IP address, IP options. Okay, this may be optional. Either you may set the IP options or may not set. That is your wish. That is the reason it is optional. Next is padding and beginning of the payload. One thing you remember, one thing you need to remember here in computer networks and communication, always there exists two types of packets. Okay, there exists two types of packets. First packet is control packets. Second packet is data packet. Control packets are one who wants to establish the which are aimed to establish the network configuration. That means identification of the routes, or maintaining the route structure, or knowing whether the devices are alert or not. This kind of things are said to be control packets. These things will be maintained by the control packets. Okay, data packets are the packets which are having actual data. Okay, so don't get confused between the control packets and data packets. Whatever the packet that is delivered at the application layer are mostly the data packets. What are the packets that are coming that are available at the lower level are the control packets. For example, ARP request, ARP reply. These are the control packets. Why these control packets are used especially? To maintain the ARP cache table. This is simple. Okay. In this, no data transmission is happening. Only what is happening here, the switch or the host wants to know what is the physical address. For what purpose the device wants to know the physical address? The device wants to know the physical address because, okay, it wants to establish a route. What is the need of establishing a route? The need of establishing route is to maintain the network configuration or routing configuration. Okay, so for the network configuration and setup, the control packets are used. Once the routing and this network configuration was set, for then only the actual data can be sent. There, the data packets will come into the picture. So ARP request and ARP reply is a kind of control packets. It is just like a VIP has to visit a particular place. VIP means either maybe the president or prime minister or these people are the VIPs who wants to visit a place. So first the control packets will go. What are the control packets here? The security team. Okay, they will be having the energy security and this kind of security. First they will go and they will check up the entire area and they will see the security settings there and everything. Okay, then they will establish the route. Okay, they will establish 2 or 3 routes to reach the destination or to the point. Okay, so depending upon the security intelligence, what they receive, okay, they may change the route all of a sudden. Okay, so they may not go in a proper route in a one manner. Okay, they will be having always 2 to 3 routes to go to the destination. So what happens if one route was in a position of attack or in a position of some problem or something? Then immediately they will change the route because they have done the exercise of identifying the possible routes. They have done the exercise of inspection of the destination area and all the security measures they have gone through and personally went and checked each and every segment over there. So because of that, they come to know the plan of how to move this VIP from his place to the destination. The same is the case with the control packets also. The control packets are one who wants to establish the network configuration. Once the network configuration is known and perfectly established, then the data packets will be transmitted over the route. So this is the way how the communication will happen. So that is the reason many of the students will confuse between the packets. So first of all, you should distinguish. What are the control packets and what are the data packets. So here IP is the protocol. Basically, it's also not a independent protocol. It has to depend upon some other protocols that we'll see afterwards. Either it may depend upon ICMP or any other thing, because IP protocol don't have any state information. Only thing is ICMP protocol will help him in establishing the route or to make the controls of the network. So that is the reason IP packet will be having only the simple fields and followed by the data payload. But the rest of the things will be taken care by the ICMP protocol only. That we'll see in the ICMP based attacks, how this ICMP based attacks will be performed, so that the upper layer protocol or upper layer packets can be tampered. So here, I hope by this time you come to know what are the packet structures and packet types, and for what purpose which packet can be used. So version represents which version of the IP header you are using. Either you are using IPv4 or IPv6. And header length. So the header length is of, in general, it is of 32 bit. It is 32 bit. Normally, it will be indicated as 5. 5 means 2 power 5 is 32. So it is around 20 octet IP address will be assigned for this. Here 32 bit means 8 bits, 1 octet. So total 4 octets will be there here in case of IPv4. The maximum header length that you can assign here is 60 bytes. So you make note of these points because these are the things very important for identifying the packet traces and making a recording of the packet traces. Next is type of service. Type of service is what type of service you want with this IP. So type of service is here 3-bit presence field. Okay. So 4 means four type of service bits will be there. One unused bit which is set to 0. So type of service bit, if you set it as 1, then it is to be minimum delay. With minimum delay, this packet has to be transmitted. And 2 means with the maximum throughput, and 3 means with maximum reliability, and with 4 means minimum cost. Minimum cost means here you are supposed to transmit this packet through minimum number of hops in the routing during routing. So only one can be set typically. Usually you can set only at a time only you can set one. Typically all are zeros for the best of effort service. If you set all 4 bits as 0, then it means that you are supposed to mention that this packet has to be transmitted with the best of effort delivery. So total length total length of the datagram. In IP, we will call it as the datagram. Okay, datagram means it can be further divided or maybe added and all. So for that purpose, we will call it as datagram. So the total length of the datagram is the maximum size is 65,535 bytes. That is 64K minus 1. So this much size is allowed to place in the datagram size. That much datagram it can carry. Next one is the indent, flags, fragment offset. So this indent, flags and fragment offset used for the fragmentation and reassembly. We'll talk about this later in this lecture only. It is just like a fragmentation in the sense. It is simple. Like for example, you might have purchased uh, a big item. Okay, you want to take it into your home, but your home main door is very small. Okay, maybe of 6x3 or maybe 8x4 or something. But that item is too heavy or too large. So what you do is you will dismantle that item and you will take it to the home. Okay, and again reassemble. Is it or not? So the same technique will be followed here. If the packet size is too high or too large, if it is unable to fit in the bandwidth or at the router level or in any network with the lower bandwidth, then what it will do is it will fragment. That means it will divide the datagram into multiple sub datagrams, and all these sub datagrams will be labeled, and it will check how much size is sufficient to pass through that channel. Okay, that much small sizes, the fragments will be divided, and these fragments will be passed through the channel, and finally it will reach the destination. At the destination end, it is the responsibility of the destination to reassemble it. The same technique like how you purchase a very huge item that will not fit into your home door, main door. So obviously you will dismantle and take it into the home and reassemble. The same technique will be followed, which is also called as fragmentation. Next one is the time to live. Time to live means this is the upper limit on the number of routers that the datagram may pass through. So this TTL will differ from the operating system to operating system. If it is Linux based operating system, the time to live will be around 64. If it is greater than 64 and around less than 128 or something, around 128, then the time to live is maintained or operated from the Windows operating system. And if it is of Cisco operating system or something, then it is around 256. So based upon the TTL, we can come to know what is the upper limit on the number of routers that the datagram may pass through. Basically, this TTL will be initialized by the sender and decremented by each router. When it becomes 0, the datagram will be discarded. That means from the source to destination, how many routers, how many maximum number of routers this datagram can pass through will be decided in TTL. If the packet has been transmitted from the Linux operating system, then you can say that the TTL will be 64. That is by default. The Linux will use the TTL as 64. If the packet is initiated from the Windows operating system, then the TTL will be 128. Okay, like that, from operating system to operating system, we can find the TTL information, different TTL information. So here example is ping -t TTL and IP address allow you to specify the TTL field. Okay, you can also try. Majorly whenever the TTLs were crossed, that means the number of routers has crossed. Then the for crossing of every router, the TTL value will be decremented by 1. Whenever the TTL value becomes 0, then datagram will be discarded. Next field is a type field. So type means IP needs to know what protocol it should handle the received IP datagram. Okay, that means what is the datagram or what is the data it is transmitting. Because IP has to know, because IP is the lower layer of the transport layer protocol. So that is reason the type you may set it as a UDP or TCP or ICMP, whatever the protocol that this particular data belongs to, that protocol information has to be placed in the type. Next one is header checksum. 16-bit once complement checksum will be maintained. So usually this checksum is used for checking the health of the datagram or data which is available in this IPv4. That means there is a chance that any of the content can be tampered by the hacker whenever he use the man in the middle attack. So that is the reason this fragment offset will always will be used for maintaining the health, checking the health of the fields and other data items in the packet. So this checksum is maintained like this. 16-bit once complement checksum will be maintained. Calculated only over header. This checksum will be calculated only via header. So this part, okay, up to padding is said to be the header. Okay, up to padding is said to be the header, and whatever the below thing is there said to be data part. So every packet will be having two components again, especially one is header part, another is main content, that is data part. So this offset is for only for calculating the header checksum. This is for header. If anything was violated, if anything was tampered in this header, then this header is invalid and the packet will not be processed by the intermediate devices or maybe destination. And this header checksum will be recomputed at every hop. Basically, during routing, the packets will be passed via multiple devices between the source and destination. So every host or every hop that it receives the packet will recompute the checksum. If the checksum is recomputed successfully and matched with the original checksum, then only that packet will be processed. Otherwise, that packet will be discarded. So this is regarding the IPv4 fields such as version, H length, type of service, total length, indent and fragment offset, TTL, type, and header checksum. Let us see one example, that is an example of IP datagram. Just like how we have seen the example of the packet structure of the ARP, in the same way, here also, I have seen here header length is 20 octets. Then type is ICMP, because IPv4 should mention, the packet should mention what type of data it is carrying on. either it is carrying on ICMP data or ICMP information or TCP information or UDP information or any other upper layer information need to be carried out in this. So type is equal to 01 here, and source IP is 128.10.2.3 and destination IP is 128.10.2.8. So you look at here 128, whenever you convert it to hexa, it will be like this 80 and 0A and 0208. This is the IP of the destination, and this is source and ICMP type 01. So like that, this packet structure will be there. So whenever you capture the packet traces, so the traces will be like this, as was shown here in the diagram: version, header length, type of service, total length, like this. So it's in sequence. Actually, packet will not be in like a box. So many of the students will confuse that. Is it like a box? Really, the packet will look like a box? No, it is a sequence. Okay. Just for diagrammatical representation, we are going to use this as a box. So how originally or how really this packets will be programmed? Okay, you can also will usually will program this packet. Okay, so how we will program this packet? You may recall structures concept in C programming. So I'm going to make it as a struct IPv4 header. Okay, version, int header length, int type of service, int total length, int indent, int flags. Like that, I will mention the data type and the corresponding field. And source IP. Source IP, I may use IP address or any other data type which supports the IP address format. And destination IP address, which is also like that. IP options, padding, and payload. So like that, the structure will be created. Whenever you write the structure, how can you say that the structure will be exactly in the square box like that? Okay. So the packet structure, in the sense, it will be always linear. But for diagrammatical representation, it will be indicated in the box. And one more thing is, whatever the size over here, so 0 to 4, 4 bits are for the version. How can you say 4 bits are for version? Okay, how can you declare it as a 4 bits? Okay, next header length 4 to 8. That means 4 bits is for the header length, and type of service for 8 bits. 8 bits are dedicated for the type of service. 16 bits is for the total length. That is the reason total length. What is the maximum size? 65,535 bytes. That means 16 bits. That means 2 power 16. 2 power 16 is equal to almost 65,535. Okay. Next, indent. Indent is also of 16 bits. So total IPv4 packet structure is of 32 bit structure, maximum length. So then, in which these are the sizes that are allotted to this. But how we will program this? For example, if I want to mention the header, IPv4 header, then it is a structure. Okay, or we can say struct packet. So what are the fields I am having? First, int version comma colon 4, which is called a bit field. Okay, even though integer occupies usually integer occupies 16 bit, but this arrangement will give only 4 bits, but only 4 bits are allotted. Okay, this concept is called bit field concept. Either int h length, header length 4. What is the next one is, what is the next field? That is type of service. So int type of service colon 8, that is 8 bits. Int What is the next field? The next field is total total length. So basically integer size is 16 bits. So no need to mention any bit field for this. By default, it two bytes. That means 16 bits will be allotted for this. So if you want to limit the size to bits, you are supposed to mention it as a colon. Okay. But if I say printf percentile %d, comma size of struct packet, so it will result into how much size. Here integer in general you say that it is a 2 byte. Next is total size is 8 bits, and here header length is 4 bits, and here is 4 bits. Total 16 plus 8, 24 plus 4, 28 plus 4, 32 bits. That means 4 bytes. So that means this structure will occupy 4 bytes, right? This structure will occupy 4 bytes. So I am going to mention another thing called here int ABC, some other field with 1 bit. I want to mention only 1 bit. Then how much size it will be occupied? Now already 32 bit exactly we have, 33 bits we got now. 33 bits in the sense, will it print 32 bytes, 32 bits? No, it won't print 32 bits. It will print that means the size of operator will always give you value in terms of bytes, but not in terms of bits. Okay, that you are supposed to remember. So here instead of 4 bytes, it will give you 5 bytes. Even though 1 bit more than the 8 bits, multiples of 8 bit is present, then it will round off to the next highest byte value. So 32 means exactly 8 bits, which is equal to 4 bytes. Till that time, no, we don't have any problem. But whenever I include this variable ABC colon 1, it is going to 33. Okay, it is going to 33. 33 means there is no proper byte size to be mentioned. So what it will do is it will round off to the next nearest byte, that is 40 bits, which is equal to 5 bytes. So that is the feature of size of, but internally the occupancy will be only 33 bits for this structure. Okay, this is the way the bit fields are used for creating the packets. Okay, so bit fields conditions are like this. Bit field conditions. Okay, first condition is bit field cannot be used. Bit fields cannot be used for used with pointers. Okay, it cannot be used with pointers. Here a bit field in the sense this colon is there, no? This is said to be bit field. Okay, in the same time, second one is bit field cannot be used with array. That means, for example, int a of 10 colon 5. Okay, if I mention like this, then it is wrong. Okay, if I say int star p colon 3, then it is wrong, because always integer occupies 2 bytes. Sorry, pointer occupies 2 bytes. So you cannot decrease the size of the pointer, which is always a constant value. So that is the reason it will result into error. Okay. Next, at the same time, array is a collection of homogeneous memory locations. You cannot reduce the size of a pack to 5 bits. That is also wrong. But you can do like this. Struct packet star p. This is valid. Okay. Struct packet star p of 10. 10 packets of this size, this type. This is also valid. Okay. So this is what the use of the bit field with which you can create the packets. That is the reason C programming is the most powerful programming for computer networks, especially for if you want to develop your own protocol, then C is the best option for developing your own protocols and to uh, deploy in the operating system like Unix environment or somewhere. The reason is the Unix system calls or the internal code is also developed in C programming. So that is the reason you can easily integrate your protocol in the Unix environment by recompiling the kernel. So this is the way how the packet structure can be programmed and can be utilized. So I think by this time you come to know how to program this packet in C programming. Next we'll move on to the other fields. So this is the way how the packet the datagram encapsulation was found in the Ethernet frame. So previously remaining things are the Ethernet frames, and here the IP frame will start, and other payload and all will go on next. Other options include the IP options. So what is this IP options? So IP options is nothing but the IP option field is not required for every datagram. Actually, this is an optional field, but options are included primarily for network testing and debugging. The length of IP option field varies depending upon which option are selected. Next one is the record route option. The record route option means whenever the IP packet has to be transmitted to the destination, obviously it has to pass through some route. So whatever the packet transmitted to the destination, whenever this record route option is on or turned on, then it will remember through which devices or through which hops that packet has been passed through. It will remember all the IP addresses of the devices that has passed through. The sender allocates enough space in the option to hold IP addresses of the routers. That is, an empty list is included in the option field. Each router records its IP address to record the route list. If the list is full, router will stop adding the list. Otherwise, the routers will keep on adding their IP addresses. This option will be exploited by the attackers in general. Next one is a timestamp option. Works like a record route option only. But what it will do is each router along the path fills the 32-bit integer timestamp. So at what time this particular this particular packet has been received and sent out. That information will be mentioned here. Next one is source routing. It provides a way for the sender to dedicate a path through the internet. Strict source routing. A list of addresses specifies the exact path the datagram must follow to reach its destination. Previously, I told you that whenever a VIP is visiting the destination, the security team will go before and will go for checking of the environment and look for the security vulnerabilities or any other thing there. Then they will decide what are the possible routes to which you can reach the VIP can reach the destination. That is what the flexible thing. That is called that is the dynamic one, because based upon the security alert raised or security intelligence report received, they may change the route. But if you mention only this is the only the strict route you are supposed to follow, that means there is no possibility of changing the route if something was gone wrong in the middle. So that is what is called strict routing here. The list of addresses specifies the exact path the datagram must follow to reach its destination. An error result if a router cannot follow the strict source route. Thereby, the packets may be lost. Loose source routing, the list of addresses specifies that the datagram must follow the sequence of IP addresses, but allows multiple network hops between successive addresses. Such flexibility will be maintained in the loose source routing. So these are the ways with which these are the ways with which this source routing and routing options will be on in the IPv4 header structure.